Alright, this is the video lesson for lesson 1.2, function notation. So we learned in class today that there's a couple different ways to write function notation, and usually the one that we are going to refer to for the rest of the semester is f of x, the function evaluated at x. Alright, so I have this example problem where we have f of x equals x plus 1 squared. That is the quantity itself, x plus 1, all of it squared. Alright, so we have three different problems: f of negative 9, f of 0, and then f of x equals 81. I'm going to go through each example and show you what exactly we need to do for each type of problem. Alright, if you ever have a function problem and it says f of a negative number, that means the input, or whatever your control variable is, you are going to plug in negative 9 into x wherever you see x in the function. Alright, so when f of x is our function, f of negative 9 simply just means the quantity negative 9 plus 1, all of it squared. That happens to be the same thing as negative 8 squared. And negative 8 squared simply just means negative 8 times negative 8, which is just 64. So f of negative 9 equals 64. Same thing for f of 0. When we have f of 0, whenever I see x, I'm going to put in a 0. So this is going to be the quantity 0 plus 1 squared, or simply just put 1 squared. And again, 1 times 1 is simply just 1. Alright, the last problem. F of x equals 81. In this problem, we are taking this output, 81, and we are setting it entirely equal to the function itself, x plus 1 squared. So let's write that. 81 equals quantity x plus 1 squared. At this point, what you are simply doing, you're not telling me anymore what the output is going to be. You are telling me the backwards route, what x is going to be, what the input is. You are solving for x. Alright? At this point, if you want to solve for x, think backwards in terms of order of operations. Right here we have this exponent of 2 up here. I want to get rid of it. The inverse of squaring something is simply just square root. So I'm going to say 9 equals, alright, when you take the square root of something that is squared, both the square root and the squares cancel, and you are simply just left with what's underneath the radical, x plus 1. This is now an algebra problem we know how to solve. 9 equals x plus 1. If I subtract 1 from both sides, I get an answer that x equals 8. Next, what we're going to look at is determining whether a relationship that we see in front of us is truly a function or not. We talked about in class that for something to be considered a function, for a relationship to be considered a function, one input has to go to exactly one output. Alright? One input for one output. So here in front of us we have a list of inputs and outputs. Alright? On our input, think of this as our soda machine example from class. If I press a particular button, the associated soda should come out of the machine. Alright? So for this example, if I press a 1, I should get a Diet Coke. If I press a 2, I should get a Sprite. If I get a 3 as my button, I should get a Powerade. Now, again, I've listed if I press 1, I should get a Diet Coke. If I press a 3, I should get a Powerade. Now we have to consider, does one input go to one output? Alright? Well, the number 1 goes to Diet Coke, 2 goes to Sprite, and 3 goes to Powerade. 1 and 3 are listed again in terms of the input list, but that does not affect whether or not the input of 1 goes to the output of Diet Coke. Just because the button 1 is presented a second time and it goes to Diet Coke doesn't mean it's not a function. It just means it's another button on the machine. One input goes to one output. So the answer would be yes, this relationship in particular is a function. Now let's look at the next relationship. Alright, same sort of thing with their soda machine. When I press a 1, I should get a Diet Coke. When I press a 2, I should get a Sprite. When I press a 3, I should get a Powerade. I'm going to skip one again, and down here again I have another 3 button and it gives me Powerade. But let's look at button number 1. Button number 1, in both cases, is actually going to 2 different outputs. Alright? An input of 1 can either get you a Diet Coke, or an input of 1 can get you a Coke. If you ever see a relationship where one element of the domain, or one input, goes to 2 different elements of the range, or outputs, that would be an example where this would not be a function.